we are answering one dangerous question. Can we trust AI agents, not chatbots, not simple prompt tools? I mean, agents that can click buttons, call APIs, write code, and update database, send emails, and take actions. And here is the core idea: you don't trust AI agents, you trust the box around them. Trust is not like personality, trust is architecture. So the game changes like when AI clicks buttons. In the old AI world, like the systems gave answers, text in, chatbots, text out, and but agentic AI changes the game. Now the AI can connect with tools, email code repositories, CRMs, customer database, payment systems, and cloud architecture. That means the question is no longer is answer smart. The question becomes, can I trust this agent like when it has the power to act? Because once AI moves from the answering to acting, hallucination is not hallucination is no longer just an wrong sentence. It can become a wrong action. Let's find out the trap. A lot of people says the only way to trust agent is to find out, that is half truth. So, and half truth is dangerous. Traditional software usually follows one predictable code path, but agentic system reason, plan, choose tools, and act differently depending on context. So, just because an agent worked 100 times does not mean it will work safely the 101 one time. So that 101 run may include like prompt injection, poison documents, broken APIs, or a completely new situation. So yes, we need evidence, but we must design the system so that when we find out the damage is survivable. So how we can treat the agents? So treat the agents like superpowered interns. So think of an AI agent like a superpowered intern and smart. So yes, smart. I mean, is it smart? Yes, and like fast, definitely. So should you give it like the full production access on like on day one? Absolutely not. You start with restricting access, then manager like review, then sc- uh, scaffold loaded and autonomy, and like only after reliability is demonstrated do you allow broader actions. The rule is simple: do not give adult authority without adult trust. And in agentic system, trust is not emotional, it is like proven through boundaries, monitoring, and controlled execution. So in the trust engineering, like no emotions. This is main message like for the whole video. Trust is engineering, not emotion. We do not just believe an agent is safe because it sounds confident. We create engineer confidence through five things: containment, verification, monitoring, testing, risking scoring, and that is agentic reliability engineering, ARE. ARE is the discipline of making agent system bounded, observable, recoverable, and measurable in the real world. So the rule number one contains don't trust. Rule number one: contain, don't trust. Contaminant like means that the agent can only do what it is allowed to do. For example, if an agent supports the customer, maybe it can draft refunds suggestions, but it cannot issue refund above a fixed limit. If an agent write codes, maybe it can open a pull request, but it cannot deploy to production. This reduce blast radius, and a contained agent do not need to be perfectly trustworthy. It needs to be unable to cause major damage when it is fail. This is how you make failure survivable. Rule number 2. So where it verifies where checking is cheaper. So rule number 2 is like verify where the checking is cheaper than doing. You do not blindly trust the agent output, and the agent proposes, the system verifies. For example, a coding agent write code, but CI/CD test, security checks, and code review decides whether the code is acceptable. In retail operations, an agent may suggest a discount, but a policy get check business rules before approval. This is the key idea. The agent should not be the final judge of its own action. The more verification you build, the less blind trust you need. So rule number 3, monitor for drift. Rule number, I mean, like in the monitor for drift, like not just failure. Agent failure is not always obvious. Sometimes the system does not crash. Instead of the behavior slowly changes, maybe the agent starts skipping steps, maybe it becomes overconfident, maybe it uses tools. Definitely. Like maybe it start ignoring the constraints, and this is the agentic drift. So we monitor behavior, not just outcome, and we track tools, calls, policies, violations, ignore instructions, and hesitation points, and unusual decisions because in agentic systems, logs are not boring. Logs are the black box recorder, and the black box recorder is that shows the difference between a mastery machine and ARE system. In the mastery machine, you only know that the task started and something happened. This is not enough. In the proper ARE system, you know the full path, the prompt, the plan, and the tool selected, the policy check, and the blocked action, the approved action, the final execution. If something goes wrong, you must know what the agent saw and what it decided and why the system allowed it. Without telemetry, like you are not running a reliable system. You are running a guessing game. So after that, like we will talk about the agent versus loop. So a powerful engine without brakes is not a better car. It's a faster accident. Like the same with the AI agents, like a powerful agent without a control loop is not reliable. The model can be brilliant and still unsafe by itself. So we do not trust the agent alone, like we trust the loop around it. And the loop includes the permission, policies, verification, monitoring, and approval gates and rollback. So there is where the real trust comes from. Trust is a property of the loop and not the agent. So let's talk about the mapping the engineered trust loop. So this is the engineered trust loop. The user gives a task, and the agent, um, the agent plans, and the system detects tools. Then the system check permissions. The verifier evaluates a human approval if required. Then action happens and feedback return into the loop, and the goal is simple: keep the unverified core as small as possible, and the more decision you can check, gate, and monitor, the less you depend on blind trust. This is how agentic reliability becoming a system, not a hype. So let's talk about one case study. So deploying an AI email agent. So AI email agent, let use a simple example like an email agent bad version. It reads emails and send replies automatically. This is blind trust. But better version, in draft replies, classifies urgency and suggested next step. But a human send the final email. Best version, it has gates, logs every action, flags suspicious instructions, required confirmation, shows reasoning, and use rollback. Same agent idea, completely different risk level. This is how ARE changes the conversation. We stop asking in the agents, is the agent smart? We ask, Is the operating loop safe enough? So there we are going to check for the production in ARE. So before like we put an agent into production, ask 5 questions. If the agent like sandbox with the least privilege, our verification gates separate from the generation model, are we logging how the agent decides and not just the final output in their deterministic rollback plan? And does the blast radius allows the business to survive if the agent goes rogue? This checklist is practical and it works for startups, enterprises, and single builders, because the problem is not using agents. The problem is using agents without a safety architecture. So we are coming on to the closing statement, that so here is the final message, that you do not trust the agent because they should smart. This they sound smart, so you do not trust agent because they passed the demo, and you trust content like verified, monitored, recoverable, and measurable. This is agentic reliability engineering. The future is not just AI agents. The future is reliable AI operations, and the teams that understand this early will not just build faster, they will build safer, stronger, and with real confidence, because in agent systems, trust is not personality, trust is architecture. Thank you.
This is Abhishek Yadav signing off from Curio Mike Show. Stay curious. Until next time, keep observing, keep interacting, and keep discovering. If you enjoyed this video, make sure to hit the like button, subscribe to the channel, and don't forget to press the bell icon so you never miss an update. Thank you for watching.